Hey, when you do these, all I'm requiring you to go is 2 places to the right of the decimal. If you can't round with the numbers they give you past that point, then use them all. I mean, if you're going to make mistakes rounding, which you shouldn't make mistakes rounding, because it's a, if I'm going 2 places to the right, like for sodium is 22.9898, then I'm just going to put 22.99. Okay, and I'm going to use that number. I'm not going to use 9898.
So we multiply them and we add them up?
Yep. Multiply and add up. That's all you have to do.
Is the CO cobalt?
No.
Or is it
No. The O is oxygen.
What?
Yep.
222.
105.99.
Yeah, 105.99 is the answer.
Maybe you do number 1 and then.
I will. Guys, again, you count each one, multiply each one by its weight, and add them up.
Is it
That's all you do.
3NO3 or is it 3ALNO3? There's 3NO3 in the second one.
That's the formula.
Oh, I know what I did.
Yeah, but
Yep, and you count each element. You guys should be able to count. What?
there's only one of them, right?
So,
Yes.
does that mean there's 3 ins?
You guys have done balancing. I should not. You guys should know how to count these. I'm not. You did balancing last chapter. You should be able to count how many you have. So, I'll leave it at that. This 4-day weekend must have took a lot out of
My addition.
you. It shouldn't have. You should have had plenty of rest. I didn't have a whole lot of rest. I had a lot of stress going on. Cold can cause you to have a lot of stress. Yep.
So can Thomas when he's getting pierced into his back?
Who?
Thomas when he got pierced into his back? That's scary.
Yeah, or Cole on the edge of the mat, taken to his back.
So we were out of bounds.
Barely.
Yeah. If Drew would have said anything, I don't think the ref would have noticed.
No, the ref was already looking. I saw the video of it. He wasn't giving any points.
Hey.
He got paid that special.
I hope I didn't get this wrong.
So who are you gonna wrestle first this state, Cole?
Sean Martin.
John Martin?
He's already wrestled him.
Julian's Owen. I lost, but it's because I did stupid stuff.
Okay, mine is not
So
coming.
you can't do stupid stuff.
No, there's stupid stuff.
So, I already got a game plan on how to beat it.
Okay,
What seed are you?
couple minutes. They don't seed him at
They don't
state.
see. They don't see.
No,
It's not seated,
if
it's
you're
just based on
if you're fourth, then you have to go against the number 1 guy in another district. If you're second, then you go against the number 3 guy.
it's like mini seed. Like if you have 4th district and you're 4th and you're 7th bracket.
There's 4 districts.
Yeah, I see what you're saying.
There's 16 wrestlers. Okay. 4. There's 12. There's 12 teams in a district. 4 qualify for state. Top 4
In each district.
in each district. And then you go to state, and then there's
4 districts, so there's 16 people in each bracket.
so there's 48. There's 48 teams in B. So the top,
16 dudes for each weight.
so then to place, you got to be the top 6 of the 48 people in state in the statewide. But they narrow it
bracket
down.
goes 16, 8, 4, 2.
I'm getting called
Yep.
from brain.
But then it's also double elimination. So if you lose
Oh.
to get 3rd through 6th, then you have to win out till you get to that round that's
So
split.
if you lose once, you can't.
No, you can't.
You can't get first or second round, but you can get 3rd or 6th.
Okay, so it's not
Kind of like the baseball World Series stuff.
Yeah.
If you're 2, you're done.
so like it's not like a situation where if you can win and then when you're wrestling in the championship you can lose.
No.
Like that's it.
Nope.
Once it's finals.
Once it's finals,
and you lose,
Yep.
then you get second.
Okay. Sometimes, like in Iowa, though, they can wrestle back to second. So,
Yeah,
like
those-
if
It's called true second.
if you get first or if you get second, say you get beat, and then the guy got 3rd, didn't wrestle yet, then you could 3rd place guy could wrestle 2nd place guy and move up.
Did you ever watch Classic D? Like wrestling? You've never.
I wrestled Classic. I mean, not wrestle. I mean, I watched
Remember
Classic.
like a Baptista?
Oh yeah, sure.
Yeah, he's not very good. I don't think. Okay,
It's awful.
all right. Did you guys get those answers?
Yes.
No, I didn't.
I
I
know,
got
two
that
12.12.
What'd you get?
You did 14.06.
This one? Well, look at which ones you're wrong, because you're wrong on one of them. Yep.
I just used 4.6.
Probably want to try to get as close as you can to, but I mean, that wouldn't take you far off if you had to use that to do some calculations with. So what these are saying is counting by weighing. That's all you're doing. So when you look at these quantities, and this 105.99, that tells you if I put that on a balance, I've got 1 mole of that substance. So what's a 1 mole? That's a lot. But we reduce it down to 1 mole so that we can use simple numbers to compare quantities. If we were actually comparing the actual quantity, then that would be that Avogadro's number. And we're not doing any of that with Avogadro's number. It's not necessary. Okay? So, questions on that. Now, why do we do this? Is so that we can use this conversion here to go back and forth between grams and moles. So why do we need to know grams? What's the purpose of having grams of something? So like you're in lab. What measures grams in the lab?
The scale.
The balance. Okay, the scale. Right? Does those scales will they measure moles?
No.
No. You have to convert them. Okay, we did a lab like that. We had magnesium. Remember, we took magnesium, weighed it, burned it, reweighed it. We got the moles of oxygen and magnesium. They had to be the same. Remember that? And then we came up with a formula that matched up one of each. Was the ratio of that. Okay? So that's all that's doing for you. So now, this is a simple task you should be able to do, is to change those grams into moles. So all we're doing is we're changing that unit of G into a mole count. So the first one, where are you going to look to get your values?
That's sodium.
That's sodium on the periodic table. You're going to get its value. That value on the periodic table tells you how many grams are in a mole. Number 4, where are you going to look to get its value? We just did it. It's right here is its value. That tells you how many grams are in a mole. Okay? So go ahead and do 3 and 4. Okay? Go ahead and do 3 and
Do
4.
we have to make like those?
Yep, railroad tracks that they call them.
Is that grams or is that moles?
Those are both grams, and you've got to find the count for them.
Is that 40 grams or is it
That's 40 decimal.
40.0?
Yep. It's 40 decimal point, not 40.0, but 40 decimal.
How many numbers
On this?
Yes.
I don't know.
Okay, so use your conversion expertise and convert those into moles.
Except for I did turn.
So 1 mole is
So on this one again, the one we just did, we're going from grams to moles. We're going to cancel them out. So those are the 2 answers that you would have for 3 and 4. Okay? Now we are doing moles to grams. Okay? Just doing moles to grams. We're finishing up review, and these are the 2 answers that you should have produced on 5 and 6. Again, we're just doing the opposite. We're just saying, if we have this count of atoms of aluminum, how much would that weigh? And it would weigh 207 grams. If we have this count of aluminum nitrate, what would that weigh? And so we weigh it out. And it would be equal to 394 grams. Questions you guys have on those last 2 examples?
Do you not want us to put it in decimal?
Well, the reason I don't put in decimal, again, there's 3 digits. I have 3 digits in the answer. 3 digits in my answer.
Significant.
Yeah, you might.
Just do it again. Plug it in again. It should round to 207.
No, because you get 206.39.
Do you?
Yeah, so
Remi's gonna be able to sign like half of mine. Cause all my keys.
So you get 206.39?
Yeah.
Okay, then it'd be 206 then.
Yeah.
What'd you do for your job?
Okay?
I just put the extra.
So we'll just leave it at that, 206 then.
Put like 21 hours for the weekend, I have to sign that set.
Questions? All right. Now, I'm going to give you, go through looking at an equation. And we're just going to look at this one here.
I hate this.
Doing everything we've ever learned in one thing.
Okay. Now, so we're going to connect some concepts here. Stuff we've done in the past,
Oh, God.
stuff we're doing now. Okay? Now, stuff we, from last chapter, we just will realize that these numbers represent values of moles. So each one of these represent a mole.
One is a mole.
Okay? So those say, this recipe says, if I have 2 moles of aluminum, then I'm required for those 2 moles of aluminum to react, I got to have 3 moles of chlorine. Okay? 6, nope, because the 3 out front says I've got chlorine molecules. So this is what this is saying. If I got aluminum, okay, that represents the mole value.
Isn't that 6 moles though?
6 moles of chlorine atoms, but 3 moles of chlorine molecule.
Got it.
Okay? And so what that's going to produce is something like this. Okay?
He probably does not even care.
So, what this is saying is that if I got 2 moles of aluminum, I need 3 chlorines to go with it. And I will make 2 moles of AlCl3. Alright? So it's a recipe just with moles. Doesn't have anything to do with grams, and we're not going to do anything with grams today. We'll do that tomorrow. Okay? So I'm going to erase something here. So we're just comparing this ratio with different numbers. That's basically what we're doing today. If I give you a number, let's say I say 1 mole. If I have 1 mole of aluminum, and I needed to use those original ratios to figure out the other quantities, how could you figure out the moles of chlorine? So like if I had to figure out the moles of chlorine that could go with that 1 mole, what's the minimum amount that I need to react that 1 mole of aluminum? 2. Okay, we got an answer of 2 moles. Anybody have a different answer?
If we have 1 mole of aluminum,
Yep. I want to know how much chlorine it's going to take to get rid of all the 1. Now I know my original, it takes 3 chlorines to get rid of the 2 moles of aluminum.
okay.
This
so-
one I'm going to say, hey, I got 1 mole of aluminum, how much chlorine is it going to take?
Okay. Wait.
You think we need 2 moles?
I have a question.
Okay, yep,
Is it moles of chlorine molecules?
yep. It's always moles of chlorine molecules, it's always moles of whatever the substance is.
It's just the ratio on it, isn't it?
I think it's still 3.
Think it's 3? Okay, we got 3 moles.
It's making AlCl3.
Alright,
Yeah.
so we got 3 moles. What else? Anybody have another answer?
Maybe
6.
So 2 or 3?
Maybe 6.
6, okay, we got 6 moles.
37.
We definitely ain't 6 moles.
Okay, what else?
It's definitely 3.
Okay, I'm telling you those are all incorrect.
5. Is that all right?
Okay, no.
12.
Now,
One
you
out of
guys,
5.
9.
Now listen, if I had a recipe and I had, the recipe calls for 2 cups of sugar and 3 cups of flour. And now I only have 1 cup of sugar available. How many cups of flour do I need?
1.5.
1.5. How can you figure that out? And this one here you
You
can
have to
figure out.
double the aluminum,
Does that make sense?
so you can't do it. It's not
How
possible.
much difference is this? What did this decrease by?
It's half.
Half. What should this decrease by? Half. So what's the answer?
1.5.
Okay, 1.5. Listen,
You can do that?
this is using the original ratio to figure out amounts. How much is produced?
We really got a half a mole up there.
1.
How we doing half?
Right? 1.
I get half a mole though.
Wait, so then,
Well, remember this mole is a large number of
We
atoms,
just got a mole.
right?
We just got a mole.
That half a mole is 3.01 times 10 to the 23rd molecules.
So then how do you figure that 1 plus 1
I thought we got it.
It doesn't equal. It's not a math problem where they equal.
so it reacts to 1 mole?
You got to use the ratios. 2 to 3. If I cut that in half,
It's all about the ratios.
it's all about the ratios, right? Okay?
How do you get 1 on the other side?
Yeah, I just.
Because it's
All right,
You're half and all.
Listen. Again, we're looking at the ratios.
Half of
2 makes 2. So if I have 1, it's going to make
1.
1 because it's the same number in front.
so say
Okay.
that,
Let's go 6 moles. Let's say we got 6 moles and I want to know how much aluminum.
6.
Okay. 9.
9. Yes. How much is going to be made?
6.
Yeah. Wait, I'm not understanding.
I did it.
Yeah, let's do it this part.
0.3.
Oh god.
Point 3?
that's Stuart.
A point.
Wait, hold on.
5.5. I don't know.
Which,
0.2.
No.
Okay.
That'd be less.
So let's see how these other ones came about. So let's
0.3 over there.
listen. So let's see how these other ones come about. So let's say, hey, Mr. Garland, I don't know how you're getting that. I need a method to show that and to calculate it. And I'll go, okay, here's the method. So on this first one, I had 1 mole of aluminum. Down here, I'm going to put moles of aluminum. And up here, I'm going to put moles of chlorine. And then I'm going to put the ratios in. This is 2, this is 3. Okay, so I'm going to take 1 times 3 is 3, divided by 2 is 1.5. Okay? Questions on that?
Yeah, lots of.
That's the
Go
answer?
right over that again?
The first one here, right?
Oh.
Okay? So, say, Mr. Garland, I can't do the second one. I'm not sure how those numbers are coming in. Why did they get 9? Then I'll say, okay, here you go. Take 6 moles of aluminum. Down below, put 2 moles of aluminum to cancel those out. And up above, put the 3 moles of chlorine. And so you go, 6 times 3 is 18, divided by 2 is 9. Okay? Let me give you one here that's an oddball number. Let's say we got 0.0243 moles. So, how many moles do we have?
0.243.
Or how many moles of chlorine do we need?
3. We have.
You guys calculate that. I want to know how many moles.
It's like 1.
No, I don't want like. I want to know exact amount. Okay, we're in science now, and you guys got to tell me exact amount. So if I have 0.243 moles of aluminum, my question is, how many moles of chlorine are we going to be required to react with
Why
that?
did the 0.3 one?
Okay, so go ahead and calculate that.
Point,
Yes.
Can I please go to the bathroom?
Yeah.
0.3.
point 36. Well, depends on how far we're going out in decimal.
Yeah, I want to know exact.
0.3645.
Alright, chill.
Okay, we'll check and see if that's the answer. I'll give you guys that haven't done it a chance to do the calculation.
I got .364.
Okay, so what should the answer be? Okay, .365. Okay, now I'm going to give you another one here so that you guys can, this is all you're doing is one step, canceling out your units of what you're given, going to what the units that you're trying to find. Okay? All right, so last one we'll do is this one.
This is basically the final.
Okay, so we're going to go ahead and give you, let's say, point, so 1.23 moles of H2, and I want to find out how many moles of NH3 I have. Okay, go ahead and calculate that. 1.23 moles of H2, I want to know how much ammonia that I have.
How did you do that? I got .4.
Railroad tracks map.
0.615. So, hold on. How do you know which one to put on top and which one to put on bottom?
Because this gives you your guide right here.
Am I looking for moles?
So wait,
That goes
why'd
down.
you put a 2 on the top? So I had a 3 on the bottom, but I put a 1 on the top.
Because we're going to ammonia.
Oh.
And are we
Okay,
That's why.
Will they ever ask just to find N2?
They can.
So then you would put N2 on the top and then
Right.
Okay.
Whatever you're going to, whatever you're trying to find,
is on the top.
well, the unit has to be expressed, so that's why it's in the numerator. Right. So 0.82, right?
Yeah.
Okay. So I've got a series of questions that you got to do for tomorrow. Okay, and the ones you do for tomorrow is on page 254, 255. And they are 7, A, and B. Check your answers as you go. 9, A, and D. And 10, A, B, C. So these are just, they give you a balanced equation and you use the ratios in which to determine what they're wanting you to find. That's all you're doing on those.
This isn't the most difficult.
Now this is the easiest of this chapter.
That's reassuring.
Yep, that's the way it is. That's the facts.
Do we have time to start this?